graph the radical expression. So here we're given a radical expression and we are asked to graph this. So the most important thing about the graph before anything else is we need to find its domain. So the domain is all the possible x values. So we want to know what x is allowed to be and what x is not allowed to be. So we're going to look, x is underneath the radical, and in order to find the domain, all we have to do is we have to take what's underneath the radical. So in this case it's x is the only thing under the radical, and we say that whatever is underneath that radical, it has to be bigger than 0. It can't be 0, or it can't be negative rather, it has to be 0 or bigger. So we say that whatever is under there has to be greater than or equal to 0. And it may be that that's some expression that you have to solve. Here I just am told that x can be equal to 0 or bigger, and that's it. But that's our domain. So that tells us what values to choose when we're going to do a table of values like this. So one thing you can always do is whatever the minimum value for the domain is, 0 in this case, go ahead and pick that and use it. So let's substitute 0 in for x. When we do that, we substitute a 0 in there. The square root of 0 is 0. 3 times 0 is 0. And so there's one of our points. So I took whatever value was there for my domain, substituted that in for x, and that's my very first point that goes right there at 0, 0. Nice and easy to graph. So now I need a second point. And truth be told, you can pick any x value you want. However, that's probably not a good idea because you're going to get some really nasty decimals and then you're graphing those and you have to guess. So let's stick with things that are going to give us nice even numbers. And that means that we want to look at when this radical goes away. So we want what's inside the radical, which is x in this case, to be equal to a perfect square. That is things that we can take the square root of. So the first perfect square is going to be 1. And so there's nothing to solve here. I just say x equals 1. So I'm going to put a 1 in there. And I say 1, well, the square root of 1 is just 1 times 3 is 3. And that gives me another point. 1, 3, just like that. So now the next thing I want to do is take everything inside there, set it equal to the very next perfect square that I would have. And the next perfect square is 2 squared, which is 4. So let's let x equal 4. Substitute that in. The square root of 4 is 2. 2 times 3 would be 6. So there's another point. So I'd get 4, 6, and frankly, that's about as many points as I'm going to get. My guess is that if I go for the next perfect square, which would be 3 squared, which is 9, that's going to send me off the top of this thing. So 3 points should be enough. And what I find is that when I connect these, every radical function is going to have the same general shape, and it's going to be kind of a swoosh like that. And I can see that these are already making that characteristic swoosh, so I graph it like that, and there it is. I have a graph for that function. Now let's take a look at another one that's going to be slightly more complicated than that and see what we can make of it. As before, the first step in this problem is to determine the domain of the function. And to do that, I want to take the part that's underneath the radical. So in this case, I have x plus 1, and I need to say that that has to be non-negative. That is, it has to be greater than or equal to 0. It's always greater than or equal to 0. You set the part underneath, greater than or equal to 0. And now what I can do is solve this for x, and I find that x must be greater than or equal to -1. And so what that does, again, is tell me where I can start my x values, where I can start looking. So I start looking at -1. So let's substitute -1 in for x. -1 plus 1 is 0. The square root of 0 is 0. 2 times 0 is 0. So my first point will be -1, 0, right there. Now for my next point, what I need to do is find where that value in the radicand is going to be equal to a perfect square. So in this case, my first perfect square is 1. And so now I can just solve this, and that'll give me my next x value. So in this case, x equals 0 should be the next value I try. Substitute in a 0. I get 0 plus 1 is 1. The square root of 1 is 1. 2 times 1 would be 2. And there I have another point. So now I'm going to come back up here and do the same thing. I take my radicand, and I want to set it equal to the next perfect square. So here 1 squared is 1. 2 squared is 4. Solve for x again. And x is going to be 3, so I can substitute a 3 in. 3 plus 1 is 4. The square root of 4 is 2. 2 times 2 is 4. So there's another point that I can graph, the point 3, 4. We can start to see our swoosh taking shape, and so our graph should look something like that.